Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at multiplying 4's, and we're going to be using something special in multiplication called scaling. Scaling is about stretching things out or shrinking things. And we're going to think about multiplication that way today. So let's start. First I need something to measure if I'm going to think about stretching things. So I'm going to make a line here. And I'm going to say this is 1 unit tall. Okay, so this is 1 measure tall. Now if I wanted something twice as big as this, if I wanted to stretch it to be twice as big, then I could make a line like this. And this line would be twice, or 2 measures, of the first. So this one is twice as tall, where this is only 1 times as tall as the original. Okay, so far so good. What about another measure? What if we did 3 measures? What would that look like? Let's draw it. First it needs to be 3 times as tall. 1, 2, 3 times as tall. So we'll say this line is 3 times as tall as the first. Okay, let's continue. What about a line that's 4 times as tall? 1, 2, 3, 4 times as tall. Alright, now we know this measure, 1, 2, 3, 4, is much more than just 1. So this is 4 times as tall as the first measure. The next one will be how many? Well, it must be 5, right? Because we're making a pattern here. So here I have 1, 2, 3, 4, 5 measures tall. So this one is 5 times as tall as the first measure. It's been stretched out. The next one, this one's going to have to be 6 measures tall, right? Let's make it so we can see it better. 1, 2, 3, 4, 5, 6 measures tall. 6 times as tall as the first measure. The next one, this one, I imagine has to be 7, right? So this one's going to be 7 measures tall. So 7 times, this is 7 times taller than this one. The next one, let's see, long stretch this time. And this one will have to be 1, 2, 3, 4, 5, 6, 7, 8 times as tall. So 8 measures tall compared to the very first one. One more, right? This one must be the tallest ever. Let's start way up here, counting down 1, 2, 3, 4, 5, 6, 7, 8, 9 measures tall. So this one is 9 times taller than the first one. So that's what scaling's about, making things go bigger, but we can also think about it making things go smaller, so shrinking. So growing or shrinking. Well, what does this have to do with 4's? Let's think about 4's together. Let me see. Let's draw a picture to help us think about it. So, what if we decided to stack 4 boxes and we thought of that as 1 measure? This is 1 stack of 4 boxes, and this is how tall it is, right? How many boxes do we have? Well, we have 4 boxes, right? What does it mean, though, if we were scaling it up to 2 times as much? How many boxes will I have? Let's draw a picture and see. So I have 1 stack of 4 boxes, 2 stacks of 4 boxes. All right, so we can see that we have twice as tall a stack of boxes here than we do here. How many boxes do we have if we have 2 stacks of 4? Well, I have 4 and 4. That gives me 8 altogether. Okay, I can see that this is twice as many boxes as this. So when I scaled it up by 2 times, I end up with twice as many boxes. What about 3 times? 1, 2, 3 stacks of 4 boxes. 3 times as tall as the first stack. How many boxes? Let's see, 4 and 4 is 8. 8 and 4 make 12. 12 boxes altogether. You can see there are 3 times as many boxes here as there are here. And 4 stacks of 4 boxes. 1, 2, 3, 4. I have 4 stacks. 1, 2, 3, 4 of 4 boxes. Okay, so how many boxes are here? 4, 8, 12, 16 boxes altogether now. This is 4 times as many boxes as our first measure. Okay, now we need to stack them 5 high. So 5 stacks of 4 boxes. 1, 2, 3, 4, 5 stacks of 4 boxes. Okay, how many boxes is that? Let's see, 4 and 4 is 8, and 4 is 12, and 4 is 16, and 4 more give us 20 boxes altogether. 5 times as many boxes here as here. All right. 6 stacks of 4 boxes. 1, 2, 3, 4, 5, 6 stacks of 4 boxes. All right, how many boxes altogether? Well, 4, 8, 12, 16, 20, and 4 more, 24. 6 times as many boxes here as here. 7 stacks of 4 boxes. 1, 2, 3, 4, 5, 6, 7 stacks of 4 boxes. What a tall stack. You can see how much taller this is, 7 times taller than our first stack. So how many boxes are here? 4, 8, 12, 16, 20, 24, and 4 more give us 28. All right, you can see how the number's growing too. 8 stacks of 4 boxes. 1, 2, 3, 4, 5, 6, 7, 8 stacks of 4 boxes. I hope they can stand up straight. Maybe they'll fall over. How many boxes? Let's count them. 4, 8, 12, 16, 20, 24, 28, and 4 more give us 32. Let's make one more giant stack, this time 9 stacks of 4 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So tall. What a tall stack of boxes. Well, how many boxes are there altogether? Let's see. 4, 8, 12, 16, 20, 24, 28, 32, and 4 more give us 36 boxes. So this stack is 4 times, this stack here is 9 times as tall as the original stack. And because every piece of this has 4 boxes in it, it's 4 9 times. Or this is just 4 just once. And so there's a different number in each of the stacks. Now I want you to look at one more thing today, and this has to do with the scaling. So let's start here at the 1. You might notice that if we start at 1, we're growing to double, to triple, to quadruple, to quintuple, to 6 times, to 7 times, to 8 times, to 9 times as tall. Okay, that's one way to think about scaling, as things being stretched bigger and bigger and bigger. So a stack of 1 is doubled to 2 stacks of 4, right? 1 stack of 4 boxes becomes 2 stacks of 4 boxes. But here's another funny thing about it. If we look at the stacks here, there are 4 stacks of 4 boxes. If we double the stacks if we doubled 4 stacks of 4 boxes, if we doubled that, we end up with 8 stacks of 4 boxes. We can see that 4 stacks of 4 boxes is just half as tall as 8 boxes, 8 stacks of 4 boxes. So scaling can make things grow bigger and bigger, or it can make it grow smaller. So 6 stacks of 4 boxes, if we made it just half as tall, would just be 3 stacks of 4 boxes. So scaling means things get stretched out or they get shrunk. Keep that in mind. I hope this has been helpful to you.